This is another example of the combined gas law. So remember, for our formula, we are going to use P1 times V1 over T1 equals P2 times V2 over T2. So this question says, a sample of neon has a volume of 29 liters at 620 torr and 273 Kelvin. What is the new temperature if the volume increased to 42 liters and the pressure decreased to 461 torr? So the first thing we want to do, again, write the formula down, and let's list our variables. So P1, V1, T1, and P2, V2, T2. So remember, one's our initial conditions. A sample of neon has a volume of 29 liters at 620 torr, so that's going to be my P1, and 273 Kelvin, that's going to be my temperature. So volume is 29 liters and 273 Kelvin. Now I don't have to change any of these units unless they're different in the two side, but if they're the same, then we could just leave these units the same, and temperature is already in Kelvin. So what is the new temperature if the volume increased to 42 liters and pressure decreased to 461 torr? Okay, so now that I have all that information, I'm going to plug my numbers into my formula. So P1 is 620 torr. V1 is 29 liters divided by T1, which is 273 Kelvin. That's equal to P2, which is 461 torr. V2 is 42 liters divided by T2, which is what we are solving for. Okay, so we are solving for T2, which is on the denominator. The easiest way to solve a problem like this is to cross multiply. Okay, so what's going to happen when you cross multiply is you are going to take this number and multiply it by this number, 273, and that's going to be on this side of the equal sign. Okay, then you're going to take this number, multiply it by this number, which is T2, and then that will be on this side of the equal sign. Okay, so when I'm doing this, what I'm going to do is take 461 times 42. Okay, so I'm going to do that first. 461 times 42. Okay, that gives me 19,362. So that number is going to be multiplied by 273. Okay, so 19,362 times 273. Okay, so again, all I did was I multiplied these numbers to get 19,362. And then because we're cross multiplying, I multiplied it by this number, which is 273. Okay, I'm going to do the same thing on the right side. So 620 times 29 times T2, all of that goes on this side. Okay, so 620 times 29 is 17,980. Again, I got this number from multiplying those two numbers up top, and we're cross multiplying, so that's going to be multiplied by T2. Okay, so the next thing I'm going to do is I'm going to solve this right here. So 19,362 times 273. That gives me a really big number, 5,285,826, which is equal to 17,980 times T2. Okay, and then when we're solving for T2, this is the variable, we just want to divide 17,980 to the other side. Okay, these numbers cancel out. I'm going to put, so this is equal to T2. So this number, which is already in my calculator, I'm going to divide that by 17,980, and we get 293, and I'm going to round this to 98, and we're looking at temperature, so this is in the unit of Kelvin.